Hello all. So today we're going to be talking about the different waveforms used in subtractive synthesis and looking at what makes them different. Okay, so I am going to be using the oscilloscope and spectrum analyzer in VPS Scope and Alchemy. So starting with the sine wave. Okay, so let's just remind ourselves what a sine wave, sounds like. Okay, so a sine wave can be described as a pure tone. Okay, so in terms of the content of it, we can see in the scope that it's very basic, and then when we look in the spectrum analyzer, we can see it peaks at a very narrow point, and there's a reason for this. So all different sounds are made up of different combinations of sine waves. These are often referred to as harmonics or partials. The difference between harmonics and partials is kind of minor from a mathematical perspective, but in terms of how we perceive the differences, it's huge. So a harmonic is mathematically the result of multiplying what's called the fundamental frequency, which is normally the lowest frequency in the sound, by a whole number. So by maybe 2, that gives us an octave. Okay, or 3, 4, 5, 6, 7, etc. So that's a harmonic. If we add a decimal point to the number that we multiply it by, we get what's called a partial. Okay, and to the ear, we notice this as being distinctly more noisy, and our ear deciphers this small mathematical difference, and it actually makes a huge impact on the way that we hear it. So yeah, the sine wave, sometimes I refer to as the humble sine wave. Okay, we can just see it's just one pitch there. Okay, I'm just going to change to a different waveform. So in Alchemy, I'm just going to go to the sources section, and we are going to load this time a Sawtooth Wave. Okay, so first of all, let's have a look at what it looks like in the scope. So we can see that in the scope, it looks exactly like the blades of a sawtooth, hence its name. So let's go to the spectrum and see how it looks different here. Okay, so what you'll see is loads more different frequencies, and these are all individual sine waves. Okay, this waveform can be described as warm and even and bright. Okay, and in terms of its harmonic content, it contains partials and harmonics. Okay, so a combination of the two, that gives it a warm and bright tone. Okay, and just to see it in the waterfall view. Okay, so moving on, we're going to look at a different waveform. So this time we're going to go to a square wave. So let's have a listen and a look how it looks in the scope. So the reason it's called a square wave, you can see that the waveform looks a little bit like a sine wave that's been squared off, pushed down. So this is actually what happens when we distort a sine wave as well, because extra harmonics are added. Okay, so this might be described as being hollow and woody sounding or nasal sounding. And in terms of the different harmonics, let's have a look at in the spectrum view. Again, much like the sawtooth, you can see that there's lots of different sine waves making up the sound, but these are only odd harmonics, and this is why it sounds nasally, woody, noisy, some might describe it as well. Okay, and then the final waveform, just load it in Alchemy, is the triangle waveform. So first of all, again, we'll have a look at it in the scope. And you can see the triangular shape to the waveform. So we'll move over to the spectrum view. And again, you'll see there's lots of different sine waves making up the sound at different frequencies. And this is often described as being sweet sounding and is softer than a sawtooth. In terms of the harmonic content, there's a small amount of odd harmonics, okay, partials, okay, and this means that it doesn't sound as kind of loud and nasally as a square wave, although it's got quite a close relationship to a square wave. Okay, thank you very much.